You know, for 200 years, a whole class of math problems has been officially stamped impossible. So what happens when a mathematician comes along and just refuses to accept that? Let's dive into this incredible claim that a 200-year-old wall in algebra might have just been smashed. I mean, really think about this question for a second. If the answer is yes, we're talking about rewriting textbooks. This is a problem that has left the greatest minds in history stumped. It's like the Mount Everest of math, one that everyone agreed was simply unclimbable. All right, so to really get how huge this claim is, we first have to understand the problem itself. Why did it get this reputation? What made it seem so impossible? So what we're talking about here are high-degree polynomials. Now, I know that sounds a little intimidating, but stick with me. You probably remember the quadratic formula from school, right? For equations with x squared. It was this perfect little formula that gave you an exact answer every single time. But what about equations with x to the fifth power, or the seventh, or the ninth? Well, that's where the math world basically threw up its hands and said, nope, can't be done. And this timeline tells a really fascinating story. For a while there, we were on a roll. Back in the 16th century, mathematicians cracked the code for third and fourth degree equations. But then we hit a brick wall, a hard stop. In 1824, a mathematician named Niels Henrik Abel proved something huge, that there is just no general formula using the standard tools of algebra, adding, subtracting, taking square roots, that kind of stuff, which are called radicals, to solve these fifth degree and higher problems. A few years later, Galois theory came along and explained exactly why. And for 200 years, that was it. Case closed. So this slide just lays it all out, doesn't it? On one side, you have the problems we can solve perfectly with nice, clean formulas. On the other side, this giant impossible barrier. A whole universe of equations we were told we could only ever approximate the answers to. This wasn't just a tough puzzle. It was treated like a fundamental law of mathematics. The book was slammed shut. Or was it? So who would be brave enough, or maybe crazy enough, to challenge a 200-year-old mathematical law? Well, let's meet him. The man who looked at this wall and simply refused to accept it. This is Professor Mourad Sultan Ezouidi. And get this, his entire field of specialty is the very thing that the giants of mathematics said couldn't be done. He literally built his career on trying to find exact solutions for these unsolvable problems. I love this quote. It says everything you need to know about his mindset. While the rest of the mathematical world just accepted this limit as an absolute fact, Professor Ezouidi saw it differently. He just refused to believe that these equations were truly unsolvable. And this right here, this is the core of his entire argument. He's basically saying, look, Abel and Galois were brilliant, but they didn't prove the equations themselves were impossible. They proved they were impossible to solve using their methods. The problem wasn't the math, he says. It was the 19th century toolkit they were using. Okay, so if the old tools are the problem, then what's the solution? Well, this brings us to his big idea, a completely new framework designed to get around those old limitations. So how does he do it? Well, the classical methods hit that wall because they were totally dependent on those things called radicals. Ezouidi's theorem just builds a bridge right over that wall because it doesn't use them at all. Instead, it reframes the whole problem, transforming it into a completely different, solvable kind of structure. So here's the basic recipe, in 3 steps. First, he reframes the problem, looking at it as part of a bigger system. Second, and this is the real magic trick, he systematically converts that messy, complicated equation into a much, much simpler linear one. And third, once it's in that new simple form, bam! The exact answers just pop right out. No guessing, no close enough. All right, theory sounds great, but does it actually work in practice? Let's put it to the test with an actual unsolvable problem. And here is our challenge, a 7th degree polynomial, a real beast. According to classical algebra, finding an exact general formula for the roots of this thing is impossible. This is the exact kind of dragon that Ezouidi's theorem was designed to slay. Now, okay, take a deep breath. You're not supposed to understand all these calculations line by line. The point here is just to show that this isn't some magic trick. There's a ton of rigorous, heavy-duty math happening here to systematically break the problem down. And then, after all that complex work, you get this. This is the big reveal. The original, scary equation is boiled down to something so simple it's almost funny. X to the 7th power equals 0. all that complexity just melts away. And from that simple form, the answer is just obvious. The exact root is 1. It's what's called a root with a multiplicity of 7, which just means the number 1 is the solution 7 times over. But think about that. Not an approximation like 0.999, not about 1, a perfect, exact solution. This is what was supposed to be impossible. So let's just pause for a second. The big question is, if this theorem holds up to scrutiny from the rest of the math world, what does it actually mean? What's the big deal? Well, the implications are absolutely enormous. It would completely overturn a foundational belief held for 2 centuries. It would mean Abel's theorem wasn't a universal truth, but just a limitation of the tools they had back then. This could blow the doors wide open for solving even higher degree equations. It would, as Professor Ezouidi puts it, restore algebra to its full power, letting it find exact answers instead of just good enough ones. And that leaves us with a really fascinating thought to end on. Professor Ezouidi's work is this powerful reminder that sometimes the biggest barriers aren't in the problems we face, but in the assumptions we hold about them. It really makes you wonder, doesn't it? What other impossible problems are out there right now, just waiting for someone to come along and refuse the boundary?